All right, here the fun begins. We're going to graph our Let It Fall lab. So, for the title of my lab, I think I'll name it Let It Fall. So, I'm going to say Let It Fall. Okay, so that's what I'm going to name it. And then I'm going to come down here and I'm going to set up my graph. Okay, so I have a ruler. If you have a ruler, you can use one too. It might help you make some straighter lines, but if you don't have one, that's okay. Just do the best that you can, okay? So I'm going to start with my y-axis, and if you remember, the y-axis is the vertical line, the one that goes up and down, okay? So I'm just going to start, whoop, and I'm going to go down to, oh, about right there, sounds good, okay? And then I'm going to bring it to the side for my x-axis, okay? So there's my x-axis. There we go. Now, if we remember correctly, what goes on the up and down axis all the time for a distance time graph? If you said distance, you're correct. So I'm going to write distance. And then in parentheses, what is our unit for distance? It's a meter. So I'm going to put meter. Okay? On the bottom here, on the x-axis, is where we put time. So I'm going to put time down here. And then, do you remember our unit for time? It's a second. Okay, so we got meter up here and second over here. Now, our distance is going to be the same the whole way through because it's just a meter, right? So let's go ahead and see if we can graph this. How many lines do I have? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll do 1, 2, 3, 4, 5. So this one right here, I'm going to put 0.5. So that's a half a meter, okay? And then 1. We'll go right about there for 1 meter. That's okay. So we've got a half a meter and then a whole meter right there, okay? Now for the seconds, if we look right here, we've got a bunch of tenths and a bunch of hundredths for these seconds, right? So this might get a little bit complicated, but that's okay. Kind of bear with me a little bit, okay? Okay, so I was looking at my times, and then I'm looking at my graph, and I think I did the best I could right here. So I've got all my lines going up to 2 seconds, okay? And I've got 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. There's 1 second right there, and then I did the same thing going up here. So I've got 0.1, 0.2, or I'm sorry, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, and 2 seconds, okay? So let's start graphing. So here's our data table, okay? I'm going to bring it back over here. And we need to plot our average time and our distance on this graph, okay? So our average time for our crumpled paper, let's see, was 0.39 seconds, okay? So if we look on our graph down here, there's 0.3. 0.39 is really close to 4. So I'm going to get my handy dandy ruler out, and I'm going to come up to 1 because it was 1 meter, and that's where I'm going to put my line. And I'm going to label it CP for crumpled paper, okay? Okay, next we need our average for our flat paper, and that was 1.75 seconds. So we need to go across the bottom for our time. There's our 1 second. We need 1.75. So there's 1.7 right here. 7.5 is right between 1.7 and 1.8. So here I'm going to get my handy dandy ruler again. There is 1.75, and I'm going to bring it up, and I'm going to put a line at 1 meter right there. Okay? I'm going to label that one F P for flat paper, okay? Because that was for our flat paper. The last one we have, come back on, lights, is our paper glider. So our average time for our paper glider of fall was 0.5 seconds, okay? So let's look at our time down here, 0.5 seconds. Boom, that's right there. Let me get my handy dandy ruler out and we'll plot this one. Here we go. I'm going to go up to 1 meter and I'm going to put a dot right there. I'm going to label this one paper glider, PG for paper glider, okay? Well, now we get to put some lines on our graph here. This is when things start getting fun. So we all start at 0. So that's going to be our starting point. I'm going to get my ruler out and go from one dot to the next, and I'm going to make a line. So there's our line for the crumpled paper. I'm going to go right back to the starting point here, and I'm going to make another line. There is our line for the paper glider. And then we're going to do the same thing. We're going to start at 0 and go to the point over here. There we go. For the flat paper, okay? Now, here we have a graph, just like we've been talking about all week this week. There's a bunch of information on this graph that we could get, right? Even without looking at the numbers, we can tell which of these fell faster than the other ones, right? We can tell that because of the steepness of the line. So the steeper the line, the faster the speed, right? So of these three, we know that this line right here for the crumpled paper moved faster than the paper glider. It also moved faster than the flat paper when it fell. So the speed of that was faster, and we can tell that without doing any math, just by looking at the steepness of the lines. We can also tell which of these lines, which of these papers fell slower by looking at the lines. You remember an at rest on a distance time graph is flat, straight across the horizontal, right? Well, if we tip this up just a little bit, we've got our flat paper there, and the closer you are to horizontal, the slower you're moving, right? So the flat paper right there is the slowest of our paper whenever we let it fall. Okay, y'all, this is the distance time graph for the Let It Fall lab. When you make your graph, I want you to take a picture of it and send it to me in an email. You can take a picture of your graph and a picture of your Let It Fall table with all of your trials on it, and show me where you did your math to find your average speed or your average time of fall, and then your average speed right here. I hope you had as much fun. I hope you guys had as much fun doing this lab as I did. Y'all are amazing, and I think you're going to do fantastic on the test on Thursday. Have a wonderful day. We'll talk to y'all later.